In May 2026, the 34th Dáil of Ireland faced a series of interlocking crises. The governing coalition was managing acute industrial unrest in the health sector, a volatile housing market, and a severe energy affordability crisis driven by conflict in the Middle East. For decision-makers, these pressures are synthesized into analytical intelligence reports. These documents provide a structured look at the state's response to geopolitical and domestic instability. The foundation of this analysis is thousands of pages of raw parliamentary record, capturing the verbatim back and forth between the government and the opposition. The raw text is interrupted by alphanumeric metadata tags, tracking document IDs and timestamps, creating a persistent digital trail. Reading these transcripts as a normal conversation provides a look at individual political arguments. However, treating the rhetoric as a quantitative dataset allows us to see the systemic patterns that govern the entire legislative session. Traditional political observation relies on qualitative human summary, but as the volume of parliamentary data grows, human analysts face the challenge of sifting through thousands of hours of debate without losing the macro-scale trends. Natural language processing, or NLP, provides the computational tools to parse this volume. It uses algorithms to identify and categorize and measure human language, turning raw text into a structured, searchable database. This official record from early May 2026 covers everything from educational disadvantage to tax codes. An NLP pipeline can identify the hidden relationships between these seemingly separate topics. By reverse engineering the May 2026 intelligence report, we can trace how these computational models extract precise geopolitical signals from the noise of political bickering. The resulting insights are mathematical outputs. They provide a structural map of the state's operational priorities, derived directly from the parsed text of the Dáil. The first step of the NLP pipeline is transforming raw transcripts into a structured corpus. The machine organizes the text into a clean database. The script uses inline metadata tags to assign each sentence a precise document ID, date, and utterance boundary. Next, the system performs speaker diarization. This algorithmically maps every spoken sentence to a specific entity, identifying where the Taoiseach's response ends and an opposition deputy's interruption begins. This creates a relational matrix that measures the frequency of interactions. It shows exactly which political actors are dominating the time on the floor and who they are directing their rhetoric toward. Diarization provides a measurable framework for the debate, turning a stream of dialogue into a chronological matrix of parliamentary combat. Once structured, the model applies named entity recognition. It scans for substantive nouns and proper names, classifying them into distinct categories. The NER model identifies international entities mentioned on the floor, extracting terms like Strait of Hormuz, Israel, and Iran as high-priority data points. In the same session, it identifies domestic and technological terms, pulling out biometric recognition, Oliver Bond House, and windfall tax. Measuring the frequency of these terms reveals an anomaly. International military entities appear at a statistically significant volume, even in debates concerning purely domestic policy. This quantitative evidence shows that external geopolitical actors are directing the legislative vocabulary within the chamber. To understand how these entities relate, the system uses topic modeling algorithms to cluster words based on contextual proximity. It mathematically links high-frequency geopolitical terms to energy keywords, revealing a strong relationship between foreign conflict and the domestic cost of electricity. This textual evidence shows the specific points on the Dáil floor where the external geopolitical shock was mapped to the internal domestic crisis. Secondary clusters form around other domestic issues. The remaining data nodes group into specific clouds representing the housing crisis and new biometric policing infrastructure. Topic modeling proves that Dáil's agenda in May 2026 was structured around managing a sequence of systemic shocks. Parliamentary debate is often saturated with performative rhetoric. To identify actual policy shifts, the model must filter out this political theater. This exchange shows how the system identifies performative noise. The classifier tags terms like hair-brained notion and meaningless as markers of high emotive sentiment. Plotting these sentiments on a timeline shows a clear contrast. The political grandstanding creates erratic, spiky lines, while the technical debate on legislation maintains a flat, neutral sentiment signature. The classifier isolates the debate on the Garda recording devices bill as a substantive policy signal, providing a clean dataset for analysis. By mathematically distinguishing between political conflict and legislation, the NLP model identifies the state's actual, grounded operational priorities. We can now map the data clusters from our model directly back to the headers of the original intelligence report. The geopolitical cluster identified through NER aligns with the report's section on the external catalyst for the crisis. The biometric and housing clusters correspond directly to the chapters on domestic policy and policing infrastructure. This reveals that domestic legislative action in May 2026 was quantitatively linked to the geopolitical energy shock. This analysis shows that the core themes of the intelligence report mirror the mathematical weight of the original debate. The frequency and proximity of terms in the transcript provide the structural baseline for the final report's conclusions. Applying natural language processing to the seat of national governance introduces a different scale to political observation. This methodology maps systemic trends across millions of words, providing a quantitative check on the qualitative impressions of observers. This approach allows for the modeling of a government under stress, using the data within the record to measure policy shifts as they happen. To understand how power operates in a data-rich environment, we must look at the structural patterns within the democratic record. The architecture of governance is written directly into the metadata of the state.